All right, let's look at the homework 15.5, problem number 10. All right, so let's do this problem. All right, so you have a function f of x, y is given, piecewise defined function. And the part A, we want to see if f is a joint density function. All right, so first thing I have to make sure is that this function is non-negative. Right, so if it's 0, it's non-negative, so that's fine. Right, you have a 0.1, then e to the, so exponential function is never 0 or a negative, so this will be fine. So this function is definitely non-negative. And another thing we need to check is that if you integrate, take the double integral of this function over the entire xy plane, it has to be exactly equal to 1, right? So let's do that. All right, so first we're going to have to define the function f. So I'm going to use GeoGebra here, and make sure to open your CAS window, so which is this guy. All right, I'm going to define f of x comma y, and I'm going to do a colon equal to define a function. So in this case, it's a 0.1 e to the negative 0.5x, and I'm going to distribute the negative sign minus 0.2y, right? Then hit enter. All right, now GeoGebra knows what f of x comma y is. All right, so we're going to do a double integral. So first I'm going to do an integral inside. So integral, all right, then I'm going to choose this one. So function is going to be f of x comma y. All right, I'm going to do with respect to x first, right? Then x is going from, looks like x is start from 0 and to infinity. So start value is 0 and end value is infinity. So to find infinity, you can click on this alpha button, and infinity is right there, right? And or if you want infinity, there's a shortcut. You can do Alt U. It gives you that too. Right, but anyway, and hit enter. Right, so that's the inside integral. Then we have to do another integral with respect to y. So I'm gonna say integral. Right, then I'm gonna use the result from line 2. So to do that, we have a $sign and specify the line it's coming from. So it's line 2, and the variable is going to be with respect to y, and starting from 0, then it's infinity. Right. Then hit enter. Right, so you can see that the double integral came out to be exactly equal to 1. So it satisfies both of those two conditions. So it is a joint density function. All right, so let's try part B. All right, so we want to find the probability where y is greater than or equal to 1. Right, so only thing you have to change is that the x is going to still go from 0 to infinity, but the y is going to start from 1. So I'm going to have to change that to 1 and hit enter. All right, so this doesn't give you a numerical value, so I'm going to say numeric. All right, then numeric, then expression is, I'm going to use the result from line 3. Then we need the 4 decimal places, so I put 4. Then hit enter. All right, so we got the 0.8187, right? So 0.8187, right? Let's go ahead and check the answer. Submit for testing. All right, I came back. Looks like A was correct and the B is correct. All right, here we want x to be between 0 and 7 and 0 and 8. So all we have to do is change these values. Right, so x is going up to 7, not infinity here. So we change that, and maybe I should hit enter here. All right, then y is going from 0 to 8. So I'm going to put that 0 instead of 1, and 8 instead of infinity. Then hit enter. All right, and you see that the number is actually automatically changed to 0.774. So I'm going to say here 0.7740. Right, let's check the answer. All right, it came back and looks like we got this one correctly. All right, so what we want to do is we want to find the expected value of x. All right, so what you do is we have to change the, so an integral is going to now go from 0 to infinity again. Right, so alter u gives you infinity. All right, then for expected value, it's very similar to the center of mass. You do x times that function. So I'm going to say x times density function with respect to x. And here we have to go back to infinity as well. So it's 0 to infinity. Right? So let's see if we can get, so I'm going to say enter here and enter there and enter there. Right? So it looks like expected value is 2. So I'm going to put 2 there. All right, let's check the answer. All right, it came back and we got the expected value of x is there. And if you want to find expected value of y, all you have to do is change this to y. All right, then hit enter. All right, looks like it came out to be 5. So I'm going to put 5 there. All right. Then submit for testing. All right, it came back and looks like we got all these parts correctly. All right, that's it. I hope that this was clear.